Hey guys, welcome to my video on 6-3A, Introduction to Statistics. So we are starting our very last section of Unit 6 and our very last section for the year before we start reviewing. So throughout this particular section, we are going to talk about data, how we collect data, what is it, what do we do with it, how we analyze it, how we organize it, and we're going to look at it from a bunch of different perspectives. So basically what today's lesson is all about, what is data and the general overview of ways we can separate it. As we move forward, we're going to start talking about how we analyze this. What are the numbers associated with this data? What does this tell me about my information? What does this tell me about the story behind what's going on? And then we'll also talk about how we organize this. So we know there are so many different types of graphs and charts that we can use to represent our information. So we're going to work on creating some of those and being able to pick out information from them as well. So here's a formal definition. Data are facts and statistics collected together for reference or analysis. So it's basically information that you are collecting that you want to find information about. Okay? You want to make decisions about. So maybe we should talk about what statistics are if we're going to be spending so much time on it. Very informally, right? Statistics basically tells us the summary of the story behind our data. What is uncovered? What is the truth of this information? What can we interpret from this information? What does it tell me about the larger group? That's the whole idea behind statistics. There's a story to it. Okay, so in terms of math, you're going to use in your everyday life statistics, and analyzing data is going to be one of those really important topics that you talk about. So there are a few ways to categorize data, okay, so that we can kind of focus our attention with what we're going to do with it. So the first way we categorize it is based off of what it is talking about. So in our first column, we have quantitative data. In our second column, we have qualitative data. What are those two things and how are they different? Well, if you hear the word quantitative, hopefully you start thinking the word quantity, right? How much of something. And that's what's going to be the defining feature of quantitative data. It deals with numbers. In fact, another name for it is numerical data. Okay? What is a key feature of this? Well, they can be measured. We can assign a value to this information. That typically means that we will have units on this type of information, right? Whether you're measuring it, counting it, it will have units. So some examples of quantitative data are age, height, length, time. Now, something else that's not written down here about quantitative data, it is separated into two types of categories within this category. Quantitative data could either be discrete or continuous. Okay? And discrete means that it can be counted, right? It is not something that continues on with decimals and fractions in between it. It's something that you can physically count. So if, let's say, you're talking about Skittles in a bag, how many Skittles on average come in a bag? Well, you can count the number of Skittles. There will not be a half of a Skittle in there. Okay? So discrete is something that is countable. Whereas continuous is something that kind of moves along, right? A continuous measurement, such as height. I could be 5 foot. I could be 5 foot and 1/2 inch. I could be 5 foot and 3/4 inch. I could be 6 foot and 4 inches. So there's a continuous range of values that I have there. So that's kind of a subcategory of information within quantitative data itself. The other category is qualitative. Hopefully when you hear the word qualitative, you're thinking of quality. Okay, how can we describe something? Okay, what is the quality of this information? So things that are included in descriptive names are in descriptive things are names, labels, categories. In fact, another word for qualitative data is categorical data, right? Can we separate it into categories? This cannot be measured, so there will not be units attached to this information. We can't measure it. We can't count it. It's something that is descriptive. So some examples of this are colors, textures, phone numbers. Now you may say to yourself, phone numbers? What do you mean phone numbers? Phone numbers have numbers in them. But let's think about quantitative versus qualitative. What makes phone numbers qualitative? Well, they're not calculating anything. Your phone number isn't measured, right? If I have a number, it's not guaranteed that the person behind me has one number past me. So it's a way to describe a way of communicating with you. Okay, so phone numbers would be considered qualitative data. Another one of those tricky situations would be something like your zip code, right? Your zip code is not counted, although areas nearby may have similar zip codes. It's really a description of where you live. Okay, so be careful and be wary of those numbers that don't calculate or cannot be measured in any way. Okay, because those are actually going to be surprising and considered qualitative data, not quantitative. Now, in terms of ways that we can represent this data, now we're going to be looking at an assortment of tables and charts throughout this section. But certain tables and charts are more suitable to quantitative data versus qualitative data because of the way that they're represented. So things like dot plots, box plots, and histograms, which we will talk about, all three of those, are going to be the types of graphs we use for our quantitative data, for those measured values. Whereas frequency tables, pie charts, bar charts are things are things that we would use for qualitative data. Now, we're not going to be looking at as many of these because we are in a math class and we want quantitative information that is measurable and can be made calculations. Okay? But it is important that these other types of representations appear out there as well. Now, don't confuse bar charts with histograms, okay? We're going to talk about the difference between those two in one of the future lessons. Okay? So that's the first way we categorize data. The second way is based off of how much information we're looking at. So, univariate versus bivariate. Uni meaning one, variate sounds like variable, so that's going to be information containing one variable or one type of data. For example, if we wanted to take everybody in the class's shoe size, okay, that is one type of data. Okay, we can average those numbers together. We can see the median. We can see the mode. We can do all these different calculations. We can make a histogram, right? 5 people have size 6. 10 people have size 8. So those are things that we're going to do with univariate information. Now, it does not represent any type of relationships or causes, right? Because there's nothing to compare this single value with, right? It's just there to tell us facts about the information. So the mean of our shoe sizes in the classroom or the mean of our heights in the classroom is not being compared to anything. Okay, we're just trying to find out information. So what are we trying to find out about it? Things called shape, center, spread, and distributions. How is the information distributed throughout the class? Do we have a lot of people that are tall? Do we have a lot of people that are short? Do most of our students appear in the average range? Okay, that would be something called distribution or shape of how this information falls. Center are things like mean, median, mode, right? The average the number that falls in the middle, the number that repeats the most. We will call these measures of central tendency as we proceed forward. And how spread out these numbers are. Do we have one really, really tall person and everybody else is average height? Or do we have one really, really short person? Or do we have a whole classroom of Miss Keys sized people? Right? That's something that we would look at with univariate. Versus bivariate, which if you think about bicycle, that's two wheels. Bivariate is two variable information, okay? We have two types of data in which we are trying to compare these two pieces of information and see if there are any causes between the two information, if there's any relationships or explanations. Now, we actually have looked at bivariate data before. Okay, we have briefly talked about scatter plots. More specifically, we paid attention to line of best fit, regressions, and correlations. So we have actually talked about statistics already. Okay, and what made all of those bivariate information is because we were comparing two sets of information, right? How closely related are those two sets of information? Did they have a correlation of 0.9? Right, which meant that there was a strong relationship. Did we have a correlation coefficient of minus 0.8, which is a pretty good relationship, but with a negative direction, right? So these were all things we did with bivariate information. Something we haven't talked about, but I believe that we will, is something called a two-way frequency table. And that's basically a table that allows us to compare two situations similarly to a Venn diagram. So we will talk about those. So now we've talked about the type of information we're collecting, what we're going to do with them. Now we need to talk about ways in which we can actually collect this information, right? That's important. How do we get this information? Because the one thing you can do with statistics is you need to be very mindful that what you're collecting tells the truth about the situation, right? So what we're doing is we're studying a population, which is the entire group that you want information about. Now, if you want to find out what America's favorite television show is, it would not be realistic to go to every door and ring the bell and ask every single person in every single house what their favorite television show is, right? It's not realistic to be able to do that. So what they will often do is they will pick a sample population, right? A sample of this population that allows us, that is representative of the population at large, but is much smaller and much more manageable, but still gives us accurate representations of the population, okay? So for example, if we wanted to poll Archbishop Malloy and ask everybody what their favorite subject is, we wouldn't want to go to every single student because there may be too many. So instead we might go to the different lunch periods and sample a few different people, right? Enough so that it tells us some information about the school as a whole, but not too many so that I'm overwhelmed with the number of information I'm collecting. Okay? Now, the issue with choosing samples is that we have to be very careful about who we are choosing as our representation of the population at large. For instance, if we wanted a representation of Archbishop Malloy student body, we would need some males, some females. We would need some freshmen, some sophomores, some juniors, some seniors. We would need people from all different clubs and all different activities involved in different parts of school life. If we just focused in on one group, that may cause some misinformation to be collected. So, for example, I coach softball. So if I wanted to ask the softball team what their favorite sport is, that would not be a fair representation of the entire school building. Okay? Just like I couldn't ask students in all of Miss Keys' math classes what their favorite subject is, because of course I'm so great that they will all love math. Also, I'm their math teacher, so they would feel obligated to say that. Okay? So these are some of the things that we have to pay attention to. So to prevent these biases from occurring, we have sampling methods, ways to create fair representation. So the first sampling method we have is random sampling, which basically is you are picking people at random. For instance, if I put everybody's name in a hat, as long as it's mixed up well and I pulled names out of a hat, right, that would be totally at random, right? So that does not have any kind of leeway towards one group or another. Another method of sampling is something called systematic. So basically you pick a number, and we're going to call this number n, at random, and then survey every nth person. For example, we can survey every fifth person that walks into the cafeteria in the morning before school, right? That will give me a good idea of the types of students. It will give me a random set of students that would be a good representation of the school at large. The other sampling method on this page is called stratified, and that's basically when you separate your population into smaller groups with a common characteristic and then survey within those smaller groups. For instance, if I wanted to survey the school, I can use stratified sampling method by breaking up students into their grade levels, right? That's their smaller groups with common characteristic, and then sample a few students from each grade level. Okay, so that would be stratified sampling methods. Now, I've been avoiding this word, but it was almost impossible not to say. If we don't choose these sampling method, we lead to bias. Okay, and basically what a bias is a built-in error which can cause the conclusions that you make to be not truly representative of the real situation. I mean, it could be, but it can be doubted. For example, the question about what is your favorite subject, if I were to ask that, right, ask all my students what their favorite subject is, they may be inclined to say math because I'm their math teacher and they think they're going to get extra credit. Whereas if you were sitting in a history class, you might be inclined to say history. Okay? So I have a few examples of this. Asking math teachers what their favorite subject is bias, right? Math teachers are going to say their own favorite subject is math. Why? Because they studied it, they teach it, they have a passion for it. Okay? So that would not be a fair representative of people in general. Another way that we can create bias is by kind of implying things with the way that you ask questions. Okay? So even just the way, even if you picked a totally random set of people, the way in which you ask them the question can cause bias. For example, if I asked you if you prefer delicious ice cream to slimy Brussels sprouts, even just by hearing the words delicious and slimy, you might be more inclined to choose delicious ice cream, just because the word itself makes it sound great. I can ask you, do you love exciting math homework or boring English papers, right? Obviously, the word exciting can push you in a certain direction, causing bias as well. Okay, so when you're collecting information, it is important to make sure the information you're collecting is fair and a true representation of the group at large. Otherwise, the statistic is not valid.